Welcome to the Explainer. Today we are diving deep and building out the definitive blueprint for running your applications on Amazon EKS in production, all the way from the first line of code to that final cloud bill.
You know, your customers, they expect a flawless experience. They expect your app to be always on, totally secure, and super fast. That's the promise. But actually delivering on that promise? Well, that's where the real challenge begins.
So how do you actually pull that off? Building something that's reliable, secure, and efficient, especially on a beast of a platform like Kubernetes? Well, it definitely doesn't happen by accident. You need a solid, intentional plan.
And that's exactly what this is. This is the blueprint. We're going to walk through the entire life cycle of an application, turning all that complexity into a super clear, actionable plan. All right, let's get into it.
So, where do we start? Well, a really solid production-grade application, its story begins way before you ever think about deploying. It all starts with the most fundamental building block you have, the container image.
I love this. The multi-stage build process, it's kind of like a high-tech filter, right? In the first stage, you've got this big workshop full of all the tools you need to build your app. But for the final product, nope. You only package the finished thing itself. All that heavy machinery, the leftover scraps, and, most importantly, the security risks, they all get left behind. And this right here, this is where you see the huge security win. A standard image, it's usually stuffed with all sorts of developer tools. Shells, package managers, compilers, things you absolutely do not need in production. And worse, those tools are a playground for an attacker. So by ripping all that stuff out for what's called a distroless image, you're not just making it smaller and faster, you're literally taking away the handholds an attacker could use to break in.
Okay, but building a secure image isn't something you do just once and forget about. No way. It's like having a security guard on duty 24/7. Every single time new code gets pushed, your pipeline should kick off an automatic scan for vulnerabilities. You can use tools like Amazon Inspector, Trivy, or Grape. Seriously, don't think of this as a hassle. It's your automated first line of defense.
All right, so we've got our secure, lean image. That's awesome. But let's be real, a perfect image doesn't mean much if the app itself just falls over under pressure. So now we've got to focus on deploying it for what I'd call unbreakable resilience, making it ready for anything. So let me ask you this, is your application really healthy? Because, just because the process for a container is up and running, that doesn't mean it's actually working correctly. Kubernetes needs to know if your app is truly ready to do its job, and it's up to us to give it the answer.
And this difference between probes is so important. The liveness probe, think of that as the last resort. It's basically asking, is this thing broken beyond repair? And if the answer is yes, Kubernetes just terminates it and starts a new one. But the readiness probe asks a totally different question. It asks, are you ready for traffic right now? If that one fails, Kubernetes is smart. It doesn't kill the pod. It just stops sending it traffic until it's back on its feet. You absolutely need both of these to get zero downtime reliability.
So what about unpredictable demand? How do you handle that? Well, the simple answer is, you don't. You let automation do the heavy lifting. This is where the horizontal pod autoscaler, or HPA, comes in. It's constantly watching metrics, like CPU usage, and the second a traffic surge hits, bam, it spins up more copies of your application to handle the load. And just as important, when that traffic dies down, it scales back down automatically. That is what cloud elasticity is all about.
Now for something called a pod disruption budget, or a PDB. The best way to think about this is like an insurance policy, but it's an insurance policy against downtime that you cause. So when you need to do things like upgrade your nodes, the PDB tells Kubernetes, hey, go ahead and do your thing, but you must make sure that at least, say, 5 of my app's pods are running at all times. It's a super simple but powerful way to guarantee availability during maintenance.
So your application is humming along, it's deployed, it's reliable, that's fantastic. But now we come to one of the most critical and honestly one of the most feared tasks for any operator, upgrading the entire Kubernetes cluster.
The good news is there's a sequence for this that turns what feels like a really high-risk job into something that's managed and predictable. First thing, before you even think about touching anything, you scan for breaking changes. You use tools like EKS Cluster Insights to see what's coming. Then, you upgrade the control plane. After that, you update the add-ons. And finally, you gracefully roll out new worker nodes. Following this method, that's the key to doing upgrades with confidence and without any downtime.
Now, I really want you to pay attention to this quote because it comes straight from the official AWS docs.
After you upgrade a cluster, you can't downgrade it. Let that sink in. There is no undo button. And that is exactly why that first step we talked about, scanning for breaking changes, taking backups, is completely non-negotiable. You only get one shot to get this right.
Okay, so at this point, your application is stable, it's secure, it's up to date. Mission accomplished, right? Well, not quite. The journey isn't over. The final act in our blueprint is all about taking that operational success and turning it into financial efficiency.
You know the saying, you can't optimize what you don't measure. And understanding where your money is actually going is the absolute first step to saving it. Now, sure, compute is usually the biggest slice of the pie, but you'd be surprised how much cost can be hiding in networking. We're talking specifically about those data transfer fees between availability zones. And the great news is, this is something you have direct control over.
So here's the thing. By default, Kubernetes services will spread traffic across all the available pods, and it doesn't care which availability zone they're in. Now, don't get me wrong, that's great for resilience, but it can also lead to a ton of completely unnecessary and expensive cross-AZ traffic. It's like you're paying a hidden tax.
But the solution here is actually surprisingly simple. There's a feature you can enable called topology-aware routing, and it basically just gives Kubernetes a hint. It says, hey, if you can, please keep the traffic local. That one tiny hint has a huge impact. It lowers latency for your users, making your app feel faster, and it directly slashes your AWS bill by getting rid of those pointless cross-zone data transfer fees. It's a total win-win.
And all of this brings us to our final, big takeaway. You know, running a perfect application in production, it's not some destination that you just arrive at one day and you're done. Not at all. It's a continuous loop. You're always building securely, operating reliably, and then optimizing relentlessly. So, is your work ever really done, or is it always just beginning?